So we're going to begin a whole new chapter, and we're going to be talking about what's called a system of equations. A system of equations. So a system of equation is more than one equation, and these equations can be any type. So, for example, we could have a system of equation that when you graph it, you have a line. And then you have another line that graphs this way, and we're looking for where the lines intersect. Now, that's the most simple, and primarily we're going to focus on that, but a system can be also this. Later on, we're going to talk about this type of function, which is called a parabola, a square function. But we could be talking about a line with a square function. And we're going to find out where those two intersect. And there's a bazillion reasons why we might want to do that. And mostly it's about limitations. Or racers. Or two things happening at the same time. And we want to see when they converge. So for example, a really quick example. One time I was sitting in Lowe's with my lovely wife. And we were trying to figure out what type of water filter to purchase. So there were two types. One was called a Brita, and the other was called a Pure.
Did you go with the Brita?
And so we did, and what we wanted to do was figure out which one was going to be the cheaper buy. But it all depended on how long we decided to keep the thing. So I'm going to make these numbers up. They're not necessarily true, but what we noticed was that the Brita started out as expensive. So let's just say it started out here at, let me just put down a number, at $20, okay? However, new filters were only about $3 each. So every few months you buy a new filter, and that's $3 each. So you go up 3, right 1, up 3, right 1. But so I'm going to make my graph look something like this, not to scale. Now, the Pure was a little bit less. It cost less. Let's just say it cost $10 each to begin with. That's the unit itself, and it comes with a filter. However, the filters were $5 each, and you had to change them the same amount. So what would we do? Well, this one's going to have a steeper graph like this. And of course, what does each axis represent? Well, this axis represents the number of filters. After I buy one filter, this is how much it's going to cost me. If I buy two filters, that's how much it's going to cost me. And over on this side is my cost. So we can see here that if we only kept it for one filter, then the Pure was a less expensive one. If we kept it for two filters, still the Pure was less expensive than this one here, the Brita. However, after a few filters, we notice they converge. And then notice that the Brita stays under the Pure after a while. So if we had to figure out, well, how many filters would we need to buy before the Brita was less expensive? And so we calculated it, a few of those, and we realized, well, we're going to keep this for long enough to make it worth our value. So we're going to start off by spending more, but over the long run, notice how much we're going to save quite a bit of money. Because notice here, the difference here gets quite drastic. And it could be in the 10s, 20s, or over the lifetime, hundreds of dollars saved. So that would be a situation, and of course I whipped out my handy-dandy TI calculator in the middle of Lowe's, calculated this thing, and was able to make my decision. Again,
Keep it in your pocket?
I just happen to have it in a backpack. So that doesn't mean you are going to do this. I'm not teaching you how you will use it. I don't know if you're going to be in Lowe's and ever do this. I'm just teaching you a place where it can be used. And the more skills you develop, the more options you have for yourself to make wise decisions as a consumer, but also to help you out in the world of work and whatnot. So here's the key thing. What we're going to be focusing on, and the solution to any system, and sometimes there's more than one solution, is it's the point where the graphs intersect. In some cases, it's just going to be one. In fact, that's where we're focusing our attention on, just the one place that intersects. However, if we don't have a graph, what we're looking for is we're going to solve algebraically. We're going to try to find a point that works for all the equations. So, for example, if I plug in a point here, down here, if I plug in 2, -1 to here, and then also in this one, if it works and it works, then I say check, I have a solution. All right, so the first thing we want to do is just test this point. So remember, algebraically, that is when you have only numbers, no graph, what we want to do is test it to see if a point works. So here's my system for whatever reason, and my point is 2, -1. So we're just recalling, again, this is just mental exercise over here. You're just remembering that your x is 2 and that your y is -1. So what you do is just substitute those values in. And when I do that, of course, 3 times 2, and then plus 2 times my y, which is -1, all equals 4. And then we're going to just simplify and see if it works here. So when I simplify, 3 times 2, I get 6, minus 2, because 2 times -1 is -2, equals 4. Now, note here what I'm going to do. I'm going to put a little question mark above the equal sign, because at this point in time, I don't know if it is indeed true. Now, of course, many of us look at that and say, oh, it's true. But let's make sure to write the true statement. 4 equals 4, big fat check mark. I know it's good to go. Now, that does not mean it is a solution to the system. 2, -1 is a solution to this first equation. Yay! Now let's check to see if it's also a solution to this one. So, again, I plug in the 2 and the -1. I'm going to put a question mark because I do not know yet. And simplify here. -2 minus 3 is equal to -5. Oh, look, -5 equals -5. Check. So now we actually have to make a conclusion. This is just you showing the work. And then over here, the point, I would say, yes, a solution. Or the solution, in fact. I'm going to abbreviate solution, S-O-L, with an apostrophe N. And when you have your answer, commit to it by putting a ring around it. So let's take a gander at the second one. Again, a lot of this can be mental. X is 5. You don't have to write that down in future. We're just walking us through it. All right, now over here, I have the x plus y equals 4. And I'm going to check that. 5 plus a -1 equals 4. And then 4 equals 4. So I see that it checks out for the very first one.
Why do you put the question mark above it?
Why do I put the question mark above it? Because at this stage, remember, with math, we're saying this side equals this side. But when I plug some numbers in, I'm not sure if it equals yet. And so now I am sure because I simplified it.
It's not like a definite equal. It's like
Right.
it could equal.
It should. We're saying it should equal, and at this point we're just saying we don't know yet, and we're confident in our lack of knowledge. So 2x plus y is the next one, equals 5. So that's a definite equal. And now I just plug and play. So 2 times 5 plus a -1 equals, with a question mark, don't know. If you prefer to put the question mark on the outside like that, that's fine too. All right, so now let's work through it. I get a 10 minus a 1 equals 5. And the answer, oh, wait a tick. This one's 9 equals 5. And that's not equal. And so we see we have a point that works for one, but not for the other. So is 5 -1 a solution to the system? And the answer is no. Not the solution. Now, here's what I'm not saying. Do not say no solution. No solution means there is never any numbers that will ever work. All we're saying is that this particular one does not work. So it's not the solution, as opposed to saying no solution. So just beware of that. Well, this one requires me to do an estimate. Remember, by definition, the solution is where the two lines intersect. So here's the intersection point, and if we look at the x value here, it's -3. And if we look at the y value here, it's at a 1. Why do I know that? Because this is 0 here, this is 2, so halfway there is 1. So what's my intersection point? It's -3, +1. All right, so that's the point that I'm testing, -3, +1. So here's my system, and I'm going to plug those in, like so. -3 plus a 1 is equal to -2. Now, what's my expectation here, by the way? I expect it to work. Why? Because I looked on the graph, and it crossed. So now we're going to finish up here. This does give me a -2 and a -2. Good. So my estimation was right when I looked at the graph and estimated -3, 2. So far, it's right. So let's try this one now. Plug a -3 in. -3 times 1 equals (9). -6 minus 3 equals -9. Great. And it does work. And I forgot the -9 right there.